Hi everyone, welcome back to my channel. I am Dr. Shbaz here. So in this video, we will learn how to perform and interpret the Kruskal-Wallis test in R. The Kruskal-Wallis test is a non-parametric alternative to one-way ANOVA. So it is used to compare three or more independent groups when the dependent variable is ordinal or continuous but doesn't satisfy the assumptions of one-way ANOVA, particularly normality of the data. Instead of comparing group means, this test ranks all observations and examines whether the distributions of ranks differ significantly across the groups or not. So in this case, we test the null and alternative hypothesis. So the alternative hypothesis states that at least one group differs from the other. However, the null hypothesis states that the groups have the same distribution. When the group distributions have similar shapes, this can be interpreted as equality of group medians. However, a significant Kruskal-Wallis test result doesn't identify exactly which groups are different. Therefore, we conduct post-hoc pairwise comparison, commonly Dunn test with the Bonferroni adjusted p-value. So in this video, I will demonstrate how to import the dataset, calculate descriptive statistics, conduct the Kruskal-Wallis test, perform adjusted post-hoc comparisons, calculate effect size, interpret the findings, and then save the complete results in one Excel file. So please like the video, subscribe to my channel, and turn on notifications for upcoming R tutorials. So first of all, I give dataset to ChatGPT for coding. So first of all, we will import dataset into RStudio. So we have a dataset of 26 30 observations where there is a participant ID and there are three methods using to keep satisfaction score, method A, B and C. So we will test the satisfaction score is higher whether in A group by B method or by C method. So first of all, we import data in RStudio. So we copy and paste the command here, then press enter. So in this way, you will see a dialog box open in front of you, and then you can select the data in the same directory and then open. So there are 30 observations. So the data has been shown on screen, you can see here. So there are method A, B and C. So we will measure the satisfaction score is higher in method A, B or C. So we will also compare by post-hoc test. Okay, next we will see the descriptive statistics and frequencies. So before applying this, we need to consult the PowerPoint presentation to see the criteria, threshold values and the assumptions of Kruskal-Wallis test. So Kruskal-Wallis test in R, we are comparing three or more independent groups using ranks. So this is a non-parametric alternative to one-way ANOVA with post-hoc comparisons. So according to our data, the test compares three or more independent groups. So we have a research context like, do satisfaction rating or score differ among students using three different teaching methods, method A, B and C. Why use this test? The outcome is ordinal or non-normal and the groups are independent. So we have a research question here. Do satisfaction score differ among methods A, B and C? So we will answer this question after performing the analysis in R. So we have also hypothesis H0. The three groups have the same score distribution. And alternative hypothesis, at least one group distribution differs from others. So we have a data set of 30 students. And we will also see the assumptions and rank-based interpretation. Assumptions, three or more independent groups. Outcome is ordinal or continuous. So in our case, the outcome variable is continuous. Independent observation scores can be ranked. Similar distribution shapes for a median interpretation as well. Practical cautions. So there are some threshold and interpretations. So in case of insufficient evidence that the group distributions differ, we need to see that the p-value should be equal or greater than 0.05 according to Bonferroni adjusted p-value. As well, Bonferroni adjusted p-value in case of testing the hypothesis that one group differs from other, so we will see that the p-value should be less than 0.05. This is alpha value. So we will also see the effect size. 0.01 indicates small effect, 0.05 indicate large effect. So as well, we also see the medium. So effect size 0.08 divided by 0.26 equal to medium and large effect interpreting context. So it means 0.05 is median and 0.08 is considered large effect size. So now we come back to our data and we are going to perform the descriptive statistics. Okay, so copy the prompt and paste in our compress enter. So we have the descriptive statistics. So you can see the satisfaction score method A. There are total 10 observation in method A, so it means there is equal distribution, and the mean value by method A is 4.1. And in case of satisfaction score by using method B, the mean value is decreased from 4.1 to 2.6. So there is a significant decrease. As well, you can see the mean value increased from B to C, which is 4.5, which is significant increase. So you can also see the median values, standard deviation, minimum maximum values. Okay, so we have done descriptive statistics, and now we will see the Kruskal-Wallis test plus post-hoc comparison and effect size. We will see by applying the prompt. We will copy and then paste in R. So we get the results. So you can see here Kruskal-Wallis rank sum test, the satisfaction by method. So there is a chi-square value 17.57 and the degree of freedom equal to, and p-value is significant because the value is less than 0.05. So if we see the pairwise comparison using Wilcoxon rank sum test with continuity correction. So we found that there is a significant association. You can see method A to B. There is a difference between method A to B, and method A to C. You can see 0.22385, and also there is a significant difference between B to C, which is 0.00072. Okay, so now we save all results in one Excel file. So in this way, R successfully created the Excel file results. You can see Kruskal-Wallis satisfaction results. So you can find the value with the same table. These are the results. You can open and interpret in your research article or thesis as well. So you can see there is data and descriptive statistics, method frequencies, satisfaction frequencies, Kruskal-Wallis test, and post-hoc comparison you can see. You can also interpret the findings there. There is a significant difference from method B to A, as well method C to A, as well C to B, because the p-value is less than in case of B to A. Satisfaction score difference between B to A and the p-value is significant because the value less than 0.05. However, in case of satisfaction score between C to A methods, there is not a significant difference because the p-value is greater than 0.05. And on the other hand, you can see there is a significant difference from method C to B because the p-value is less than 0.05. In this way, we perform the Kruskal-Wallis test in